We'll be starting off contrasting trial and error and insight. We'll kind of see that these are two kind of opposite ways of problem solving. Then we'll look at problem solving through analogies. We'll look at creativity, confirmation bias, and problem solving and what's called the problem space. One early approach to problem solving came from Thorndike, and if we think of what a problem is, it's a situation in which a person is motivated to reach a goal, but there's some obstacle that blocks the attainment of that goal. Thorndike, if you remember, was an early American psychologist. He was an early American behaviorist, and as such, he was really focused on the importance of the consequences of behavior, and he tended to disregard the influence of any type of mental processing.
But how is a new skill learned? That was a question which began to fascinate Thorndike. To answer it, he built some ingenious puzzle boxes from which cats could only escape by operating latches.
And in you go.
The cat appears to be very clever in engineering its escape, solving the problem with a deftly placed paw and a push of its nose. But Thorndike didn't believe that an animal, even a clever cat, understands the consequences of its behavior. When he placed a cat in the puzzle box for the first time, Thorndike was unable to see any evidence of flashes of insight. The successful actions appeared first by chance. He proved that the apparent cleverness arose by trial and error, and used graphs to measure the rate of learning. A well-practiced cat quickly recalls the actions that help it escape to its reward of food. If an action brings a reward, Thorndike believed that that action becomes stamped into the mind. In his thesis, he explained further his ideas about learning, that behavior changes because of its consequences. He called this his law of effect.
Thorndike attributed the learning of animals and humans to the consequences of their actions, and proposed that animals and people then solve problems through the process of trial and error. You just try different things. Some things work, and if they have a good outcome, that will reinforce that behavior in the future, and you'll be more likely to do it. If it doesn't work, it's not reinforced. And he really didn't think that there was any sort of insight or any sort of mental processing or considerations going on. In contrast, Kohler suggested a very different view of problem solving. He felt that insight was quite important, and not just in humans, but in animals as well. That an animal internally or mentally explores a problem before responding to its environment, and that the exploration involves considering and rejecting possible solutions and finally developing insight as to the correct solution. So there's sort of a type of practicing involved when considering different solutions to a problem. So let's take a look at how insight has been studied in other animals.
At the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, psychologist Joseph Cole places a peanut inside a clear tube. How can the chimpanzee get the snack? She's never seen this puzzle before.
For 10 minutes, there is no solution in sight. And all of a sudden, boom, they solve it. They have to understand that they can use the water as a tool. This is interesting because the water itself, it doesn't have any shape.
Using water as a tool seems like something we would do on a good day.
So isn't that an amazing demonstration of insight? I think that I would probably not have figured out to use the water as quickly as that chimpanzee by any means. So definitely researchers that work with other species have definitely found lots of examples of animals being very good problem solvers and of being able to approach problems and represent them internally, mentally, and not just use trial and error like Thorndike said. You can kind of see that trial and error and insight learning are the two opposite ends of a continuum. We probably use both in different situations, certainly, and we're certainly capable of using both. So let's take a look at